It's been a while.
Jordan Lake, great to see you.
About a year ago, we recorded a video trying to walk through Urbit, and we put it on YouTube. And neither of us really understood what we were doing very well. Um,
Seriously.
but we have, I mean, if, like more than a few people have reached out to me requesting that we do a part two to this because they're interested in the technology. And you have been working at Tlon for probably like a year now, right?
Just about nine to 10 months.
9 to 10 months. And yeah, and I think we're ready to do a part two of trying to understand Urbit. And yeah, so one thing that I've come to realize in like the past couple like weeks that I've been thinking about this is it fair to say that Urbit is trying to be a replacement or an alternative to Linux?
Completely. Yeah. In the long term, at least. I think the overarching thesis is that, as incredible of a system as Unix and Linux and all these things have been for the last 50 years, at the end of the day, they're bringing with them a tremendous amount of incidental complexity. Millions and millions of lines of code, some of which are still like, basically ported systems from the 70s and 80s, right? So it'd be great if we could just start all this over from scratch, not as a way to kind of simplify the user experience for regular people, but actually even just to build better software in general. You'll notice, we'll get into this a little bit later in the video, by sort of rethinking some of the fundamental axioms of computing itself from the core, like the very core essence of the stack. You can end up building dramatically simpler systems that are, it's funny, a lot of people, will look at Urbit and they'll see this totally crazy project, but even to people who don't have much of a technical background and they look at Urbit for the first time, it actually looks a lot more sane, I think, when you understand the core ideas. But if you're already an experienced programmer, learning Urbit is this giant feat. So we've been trying to improve our documentation and our examples. That's kind of been my job. I've sort of been trying to take over that effort and lead the community forward and make people realize that, Urbit is actually simple and it's fun and it's definitely approachable.
Yeah, I think again, that's the thing that's kind of gotten me to the point where I'm like, okay, because once you realize you're trying to replace Linux, that's why it makes no sense, because I just take Linux as like an assumption of software development. It's like, yeah, of course you need to be on top of Linux. And once you remove that, you're just like in outer space and you're just like, well, now I don't even understand anything that's happening.
Totally.
And then I think that's where a lot of the confusion gets in, is that there's like all these, sayings and axioms and like, oh, this makes computing simpler, but like people don't have the grounding to really wrap their heads around it. So I think what we're going to do right now, which is going to be really interesting, is just forget about all the talk and mumbo jumbo and let's just actually try to build something. And I'll just ask you questions along the way and we'll see where we end up and how far we can get. I think it could be pretty interesting.
Totally. Yeah, that sounds great. Let's show off what this thing can do.
Yeah. So what's the the very vague outline for this little pair programming session is that we're going to try to build a Twitter clone using Urbit.
Yeah.
All right. Let's do it. Where do we start?
So I think, my sort of idea, it really depends on how long this goes. We could end up talking about, there's just so much to talk about Urbit. We could be talking for 2 hours and not even finish the clone. But nonetheless, I think we should first kind of show off, let's kind of walk through the thing about Urbit as it's, mostly, documented, and there's not a lot of, the documentation is getting better, but it's like with Ethereum or these other systems, you can kind of Stack Overflow something, or you can look something up on YouTube. And there's so much more programming for a platform than just like, oh, here's how you do X. It's more just like, oh, how do I even get set up? Where do I go to find help?
Right.
Where can I look at the documentation? How can I make this workflow really simple and fun and fast for me to use? So I think we should even just go through that before we even delve into the technical side of things.
All right. So if I was going to try to make a Twitter clone, I would start trying to figure out how to get documentation or something. So.
Well, first you gotta get Urbit, right? You gotta install Urbit. So I know our last video we did, we were having some troubles because I was still pretty new to this, but it's actually way simpler than you think. If you're on a Mac, or even a Linux, I guess. So Urbit runs as a process on top of Unix. If you do run Windows, I think we've had a few people semi-successfully run this on the Ubuntu on Windows thing. But generally speaking, you should be on a Mac or Linux or get a Linux box in the cloud. So yeah, I mean, but if you're on a Mac, it's literally just brew install Urbit and then create an identity on the network. And within 5 minutes.
What are you actually installing when you brew install Urbit?
Yeah, so we can kind of talk about this a little more in detail later, but the whole Urbit operating system. So Urbit is an operating system, and it's so it's an operating system written in a purely functional programming language, which compiles down to what's essentially a functional bytecode called Nock. So the operating system Arvo is written in Hoon, the programming language, which compiles to Nock. And the spec of Nock literally can fit on a T-shirt. The design goal was to make a virtual machine that was so simple that it could basically run anywhere and is portable, and it kind of decouples the implementation from the semantics. So you can imagine.
Is this similar to Java in any way? The way that like you have a Java bytecode and a JVM, or
that's probably the closest analogy. I think the most staggering difference is that, like, the JVM, of course, it's an incredible feat of engineering, performance-wise and security-wise and all this stuff, but it's massive, millions and millions of lines of code. Oracle is a multi-billion-dollar company, thousands of engineers that maintain and update this thing. And Nock, the kind of formal interpreter, the actual and kind of the raw interpreter is only a few hundred lines of C. But then, and we can talk about this a little bit later, to make some performance optimizations, you do need to kind of add some other lower level C files to make things fast, given the limitations of Nock fundamentally. Okay. So so when you brew install Urbit, you're downloading basically the interpreter, which will run. It's enough of you're basically downloading the virtual machine, and then that's going to allow you to start a process when you boot your Urbit for the first time, which will pull the core Urbit, first Urbit events basically over the network. And then from that, you'll be able to bootstrap an Urbit.
Gotcha. Yeah. And by the way, the fact that you can do that in and of itself is probably interesting, because like you definitely can't just brew install the JVM.
Yeah. Well, I mean, what we could do right now is like we could just clone the repo and like just check it out real quick. So like if I just go, is that working? Can you see my screen and stuff? Cool. So if I go, Urbit/Urbit, putting this in Urbit. Cool. So, oops. So right now we have, generally speaking, we kind of have two main branches. So, I think that's branch. Yeah. So we have kind of a maintenance branch, which was running on the live network right now, and then we have a master branch, which right now we've kind of had a lot of work on separate branches, and we're trying to get this all organized so that one problem with the repo right now is there's been a tremendous amount of activity on the Urbit project by all of us, but it's actually not super obvious just by going to the repo itself.
Can you go to Urbit on GitHub? Like, is this just an open source GitHub project? So is
totally.
You're doing open source?
Yeah, totally. Yeah, everything is free and open source. So, so here's Urbit/Urbit. 1,300 stars. Most of those are from kind of the original Hacker News posts, I think. But I mean, nonetheless, so yeah, I mean, most of this repo is written in C, of course, and so var is is kind of our code word for the virtual machine, and that pulls in the Nock interpreter, and then there's some other kind of performance optimizations in here.
Gotcha, cool. Yeah, I didn't even realize this was just on GitHub, so that's
so then, generally speaking, so that's the interpreter. All the Hoon code is in a different repo called Arvo. So this is the Urbit operating system,
right.
And we don't even have the syntax highlighting on GitHub for Hoon. So it says that this is all JavaScript, but actually, if you look, all this is Hoon. The whole OS is written in Hoon.
Yeah, they don't have syntax highlighting for Solidity either. It's really obnoxious.
Yeah, so I mean, this is something that I should get on. Exactly. But then, yeah, even better. I mean, docs are just markdown files that you can pull request and install.
All right, cool.
Our examples are great. So, yeah.
Cool. All right.
So, why don't you install Urbit? So, if you did want to build from source, you could do that. And we'll actually do that a little bit later. But for now, it's kind of the easy install. All you have to do is brew install Urbit.
Yep.
And this will take a quick second. Of course, it has some dependencies. It relies on OpenSSL, libv, Curse's implementation for terminal driving and events and whatnot, and some other dependencies. But yeah, I mean, that's pretty much as simple as that to install it. So should have Urbit now. So then,
so this is just a binary script, and you just run Urbit, and then you start it.
Yeah, so I want to create an identity. So I just picked a random name. That's just the name for the folder.
So -C, and then the name is your identity on the network.
No, sorry. The name is just it's the name of the folder that it's an arbitrary name. You can name it my comment or my folder, my Urbit, whatever. So I just picked a random name.
Gotcha. Yeah.
So then when I want to restart my Urbit, I'll just run Urbit and the name of that folder.
So what's the level of abstraction to think about your Urbit? Like, is this just like an EC2 instance? Like, would that be a fair parallel kind of?
So an Urbit is a personal server. So ideally you'd have a planet, which is, you can talk about the different levels of Urbits and the networking hierarchy, but you have a user level Urbit that runs in the cloud. And there's a limited amount of these. So what's great about that is if there's a market price to acquire one of these, and there's a finite amount, then if basically it costs more to get one, then a potential spammer or abuser could potentially abuse that privilege and make money, then overall the network should be mostly spam free. And everybody would have a default positive reputation, which is really, really cool in terms of the dynamics is how you really bootstrap social infrastructure. This kind of goes back to like Usenet in the old days. So like the only way to get on Usenet back in the 80s, 90s was if you had a computer, with this $1 million machine at your university, right? And if you abused that privilege, then you didn't get to use this computer anymore. So sure enough, the whole network was very friendly and tolerant because, if you trolled or if you spammed it up, then you just lose access.
So I do so it's like the whole thing that's so interesting with cryptocurrency about digital scarcity and the different dynamics that evolve from that. But like, what is actually the thing that's scarce? Like, these are like computers kind of, or it's like the address space is scarce.
So an Urbit really is four things. So an Urbit is, it's a Turing complete computer. So, they can do anything. It's a cryptographic identity, which you own with the private key. It's a pronounceable name, which we'll talk about later. And it's a network address in the network.
So the thing that's scarce are the addresses, because like you could have the Urbit, like even if you weren't on the network, you'd still have the Urbit computer.
Yeah, the way to think about it is there are 2 to the 128 addresses in Urbit. So it's a massive number. It's almost an infinite amount of identities. But in order to identify those nodes on the network, they have to have an identifier, which in this case is just a number, right? So it's orthogonal or parallel to an IP address, right?
Right.
So inherently, there's kind of a limited amount of IP addresses that are short, right? You could have like an IPv6 address, but that's a massive number, and so as a number gets longer, it's harder to remember. And generally, because there's a lower amount, because it's a higher amount, there's a lower value. So again, there's potential for spam and whatnot. So kind of as you shorten the numbers, the shorter names basically are more valuable.
Where does the registry live of all the names? Like, where does the registry of names actually stored?
That's a good question. So this is it's bootstrapped or it's written hard coded in the Argo operating system, so that like we just take a number. So like in the public internet, you might have an IP address like 192.1.2.5 or something. And we just take that number and convert it to a pronounceable name. So like my name on the network is Tumblr Seret, which maybe sounds like a name in a foreign language. It sounds a little alien, but it's actually memorable and you can say it out loud, which is pretty cool. So then so we just booted our Comet, which is it's one of the 128-bit identities, which is basically they're essentially infinite. So anybody can make one for free, which is why it's so easy to get up and running. So you'll notice like our name is super long.
Yeah, the reason why that thing that is showing up, that's the name of the Comet, basically.
Yeah, so this is actually literally the number of the identifier of our common right now.
Right. And this is one of the 128-bit identifiers. And the shorter of an identifier you get, the more scarce it is and the more valuable it is.
Yeah. So maybe this is a good time to talk about the network hierarchy. So the network is built in a hierarchical manner. So the network starts with 2 to the 8th galaxies. So a galaxy is something like Zod. And then every galaxy can essentially issue or create 2 to the 8th minus 1 children, so 255 children, which are stars. So a star might be something like Marzad. And so in total, there are about 65,000 stars. So galaxies and stars act as network infrastructure that do peer discovery and routing for their children, which are planets. And planets are user level. So a planet might be something like, Master Morzad. Oh, hey, so we got a little Easter egg. So we ran some Dojo commands. So if I did actually want to get rid of this comment name, I could just run this command right now, which I'll do right now.
So what is that? What actually is that function that goes from the numbers to that human readable name? Because that's like kind of interesting.
Yeah, I mean, you could look at it in the code. So let's see. Why don't I? Let's see.
But the idea is that it's like you could figure it's just some function that goes from a number to a human readable name, and you can like predict how it's going to do it. It's like,
yeah. So why don't we clone Arvo, which is the OS?
Right, and Arvo I've deduced is the operating system.
Arvo is the operating system, which is written in Hoon.
Which is written in Whom, which is a programming language that compiles to Knock, right?
Yeah. And we'll go into the bare bones of Hoon and Knock later in the video, just so everybody's not freaking out.
Yeah.
In Arvo, Arvo is built of 7 sort of kernel modules, which we call veins. So your Urbit comes with 7 veins. Actually, I guess now there's 8. Ames is the encrypted peer-to-peer network. Bane is the system timer for events and whatnot. Clay is a global immutable file system that's referentially transparent. Later we can go into what all this means and its implications and stuff. Dill is the terminal driver, so the fact that you can talk to my Urbit through terminals, doing that through Dill. Air is a web server, and it's how you talk to your Urbit over HTTP through the web. Ford is a functional build system. Ford is maybe the coolest of all the veins. It's really cool. And then Gall is the application sandbox. Soon, when in the new the next big release of Urbit we're going to release, we'll also have Jail, which is where you'll be storing your crypto secrets in your private key, and if you have API keys or general secret storages, and we want that to be secure at some point, obviously. But of course, we're not audited yet. Hoon, of course, is the Hoon language, and then Zeus is the Arvo standard library. So there are common interfaces to deal with. For example, we have a type specification for JSON so that you can communicate easily over the web. That's not defined in Hoon.Hoon, that's defined in Zeus because it's kind of an operating system level thing. Cool. So yeah, I mean, oops. So before I boot up my planet, let's just kind of go along with this.
So like the only thing really that we've run is just to install Urbit, and then you
get dropped into So this is your dojo. So
this
the dojo
is the default prompt that occurs when you run Urbit.
Yeah, so it's like if you boot a new Ubuntu box, you get dropped into like a bash shell, right?
Yeah, exactly.
So sort of similarly in Urbit, once you boot one up, which takes about 5 minutes, you get dropped into the dojo, which is a combination of a Hoon REPL, or you can evaluate Hoon expressions. And then there's a special dojo syntax for interacting with your operating system. So you can kind of similar to how you ls on the command line, you can do this, which does ls of your current desk, which is sort of your current directory that's version controlled. You can go into that a little bit more too, or you kind of have the basic sort of Unix commands. We have kind of
gotcha. So the dojo is the dojo is the prompt, but you're basically on a file system here. Like when you're in the new Urbit, you're kind of in a file system, it looks like.
Yeah. So I think this will kind of manifest itself more as we go through the video.
Okay, cool.
We'll like sync some desks or merge some desks, and then we'll kind of move around the file system, and we'll be able to kind of show off the coolness of the version control stuff.
Roughly think of this as like we're in a computer. We're in some sort
of Urbit is a computer. It's like the simplest way to frame it.
Cool.
So yeah, and it's like if you wanted to run your own Facebook server or Mastodon node or something, it's fairly difficult, roughly speaking. Like it's something that, my mom wouldn't be able to do, right? Urbit right now is nowhere near that stage either of usability, but it'd be great if at some point, like you've noticed, even just like installing Urbit and like booting one up and, I'm interacting with command line.
Node.
Exactly, right? Yeah, which we can talk about our Ethereum plans too. But the point is, like, it'd be great if Tlon, which is the corporate vehicle who's building Urbit, the open source project, it'd be great if at some point we got into sort of automated hosting where you sign up with email, just like you'd sign up for Instagram or something, and then it just booted an Urbit up for you and dropped you right into a cleanly designed web interface.
Cool. All right. So
So why don't we? What we should do is. So I want to, this long name is going to get really annoying. So I actually want to boot up a planet. I just wanted to show this off to show off that like getting on Urbit is not hard. You just have to run this and then you can follow our doc setup instructions to drop in a talk and you can get help that way. But really like if you want to do real development and be part of the community, you should get a planet. So I say we do that.
And by planet, you really mean shorter address.
Yeah. So planets are.
But the actual functionality is the same, or the functionality is different.
The functionality is exactly the same. You run, well, sort of. You run the same OS, but the only difference is planets or stars or galaxies or whatever. The different tiers of the hierarchy might have certain privileges that lower tiers don't have. So, for example, like it'd be trivial on Urbit to, let's just say you wanted to watch a YouTube video, sort of Urbit YouTube video, but you want to get rid of all the spam or troll comments on the video. You can trivially filter for, hey, if this is a 128-bit address, if this is a comment, just don't show the comment. I only want to see comments by people who are kind of like brave enough to reveal, who they are and have a single identity. So planet's really cool, especially for development. Like people just get to know who you are.
So the way that you're getting a planet right now is via like a manual invite that you have.
So I asked Marzad to send me an invite, and then we manually approve these. So I have
you booted a comet, and then you asked for an invite to a planet. Now you got it, right?
Yep. Yeah. So we manually approve the invites for now. So I just approve one for myself because I have secrets. So then I got an invite to my. So what else is cool? Something else to point out is like this was all done on Urbit with an API connector to Gmail. So we have a star that's hooked up to Gmail, and whenever it kind of watches for these ask events, it sends a thing out to Gmail. And now you can kind of a decent way to explain Urbit is like man in the middle of yourself. So you can kind of like everything that you want to compute, like you should kind of have a central point of control that you own control and that you own cryptographically, and then you can kind of tap out to other services if you need to.
That's a funny analogy. I have to think about it.
yeah, totally.
Cool.
So nonetheless, we have an invite. Let's see, which of these names do you like? Do you like these? We get Pitzer. Do you like this one?
Yeah, let's do it.
All right, let's do it. Oops. Claimed. Cool. So I should might have to wait a bit. Marzad is a tad slow. Well, we can keep playing around here. So
so like we're just waiting for the planet to get like the credentials to get emailed to you.
Yeah, it should just take a minute. So yeah, again, this is a human rep. So I just stopped my thing. So yeah, if I booted one like this with -C and I want to start up again, I just do this and I boot right back up.
Gotcha.
What's really cool about Urbit, and we can go, again, we're going more of the fundamentals, is that every event on the system is transactional. So Urbit is also an ACID database. It's ACID compliant, which means that if I am typing, something in the middle of my thing, and then I violently kill my Urbit, if I boot it back up, it's going to play back the events, and I'm going to be right back in the prompt where I started. So literally, like this actually literally happened to Ted, our new hire, just a few weeks ago. He didn't know that if he shut down his Ubuntu laptop in the middle of anything, just like hard turn off, it like literally corrupted his file system, and he had to reinstall everything from scratch.
Wow.
Which is something that, if you make an operating system that's purely functional and immutable and all this stuff, and that's event oriented, you don't have these problems, which is really cool.
Yeah, that is. Wait, so have you ever used Nix OS?
Yeah. So Nix is
similar to that.
At the end of the day, Nix is still Linux, right? So they're making things a lot easier, or I should say simpler, more functional, and that's all great progress. And Linux isn't going away anytime soon, especially for cloud infrastructure and whatnot.
Yeah,
so hopefully, it'd be great to see that project succeed. We would love to use Nix, because Urbit's going to run on a Unix box for the foreseeable future. So more kind of like functional and stuff.
Yeah, and just for people that are listening, Nix OS was, I think the idea is that you have like an immutable kind of state transition of every state change you make to your Linux file system. And like that way you can always just get back to exactly the state that you were in, or roll back if you need to, or something like that. And that's what this seems similar to, which is really interesting because like.
Yeah, totally. So cool. So I got this email from Marzad from Urbit.org with my ticket to my plan. So let's, I'm going to copy this. And then graph tick pincer. So let's shut down comment. What we should actually do, and I already have this set up, so it should be pretty fast, is I'm on my local laptop right now. Ideally, like you really want to run your planet in the cloud. And the reason why is it's just so much faster. You can like access your Urbit from your phone, which is cool if you just keep it running in like a tmux session. And then eventually when we have cool API plugins to like say Twilio or your email. So it's like every time there's a new fora post or every time you get a direct message, it'd be cool if it just like came to your phone, right? So the only way you can get that cool functionality is if your thing is running in the cloud all the time.
Right.
And then for development, which we'll kind of go into that very quickly. And then like, we want to get building stuff. So for development, we should run kind of like either comments or fake ships locally on our own machine. We shouldn't necessarily tap up to our planet in the cloud. That's just kind of for like talking and stuff.
Gotcha.
So,
yeah, that makes sense.
I have just a thing running already. That's cool.
Oh, so this is just an EC2 instance or whatever.
It's DigitalOcean. So it's just 1.2.16. So, everybody watching this is probably fairly technical. Should know how to boot a Linux box, but DigitalOcean is great if you're kind of new to that stuff. I should have Urbit installed. Oops, not Urbit.
Urbit. Yeah.
Or maybe I don't actually.
But we know how to do it, right?
I just, so I installed Linux Brew, which is, I found to be like, it's a little janky, but it's,
I used it, yeah.
It's really cool actually. So I think this should work. I might have to build it from source, but.
Why wouldn't it, man? I have faith.
Exactly. I mean, I did this, I tested this earlier, so it should work out. Anyways, man, but, let's see. So we should also just kind of be upfront. Like this video, we want to go like glacially slow. We want to make sure every single thing that we touch and talk about is clearly understood. So is there anything that's kind of confusing?
The half hour that we've been recording so far has been the most sense Urbit's ever made to me. So we're going so far so good. You might need to, like actually take the binary somewhere or something. Oh wait, you also might have spelt it wrong when you did the which. Hold on.
No, I messed that up. Well, actually, it's actually not that hard. We can just
you can just clone it from source.
Yeah, I can just. It's not the worst thing in the world.
Yeah, no worries.
And this is actually what you should do. Can't type today. I mean, like it is good, like especially as we're kind of like maintaining updates and stuff. It's good to kind of always stay tuned to our latest changes and whatnot. So let's see. Actually, we might need to. We have sort of a. There we go. So we have install page for docs where we, if you want to build from source, you have to install some dependencies, which is kind of a normal thing. So actually, what we could do is let's just download the source tarball here. That's better. So then we'll.
You're gonna need to SCP. I see an SCP
exactly.
in the future.
Exactly. Can I just
What the fuck? I never knew you could do that.
Yeah.
You can just drag files onto your command prompt. My God.
Yeah, it's pretty savvy, right?
Yeah.
So then, oops. There we go. So then, have you seen that XKCD of you have to disarm the bomb by knowing the tar command? The guy's like, I'm so sorry.
Yeah.
That's pretty great.
That's pretty funny.
Okay. Actually, they didn't help us because we still have to install dependencies. Sorry. That was a brain lapse. It's a little one-liner, makes it helpful.
Yeah, it's still probably easier than installing the JVM, so you're good.
Seriously, come on.
That's your standard.
This is ridiculous. Okay, let's do this. Oops.
Honestly, my assumption is that it did work, and just the binary is not in your path or something.
There we go. Yeah, something like that. Let's see. Oh, maybe I need to do it. Stupid DigitalOcean.
Yep.
Should be better. And then we can edit all this out, of course, hopefully. Or maybe not, I don't know. So, yeah, I mean, the long term, of course, there's a lot of sort of dependencies for running Urbit. It'd be great if we could chuck those down and, eventually as we get more resources and stuff.
Is your plan to actually write a lot of this shit in Knock? Are they going to try to, or Hoon, are they going to try to do that?
It's a little more complicated than that. Right now we're working on actually rewriting the interpreter in. There's a JVM platform. But there's kind of two things called Graal and Truffle that are basically super optimized compilers. They you can basically define your spec and it just super optimizes. So we have a guy working on this, and our interpreter running on that is 15 times faster than our current one.
Oh, gotcha.
So it's just super cool.
You're ways away from writing Linux utilities in Hoon.
Yeah, seriously.
Gotcha.
I mean, yeah. So again, the spec for Knock is not language specific. It's just a spec. So you can write this in Rust, and we have people have done this. We have probably 12 community Knock implementations on our website with people written in Python, JavaScript, whatever.
Cool.
Okay, so I have all those dependencies. I have this installed, so I should just be able to make. That should be good, or not. Oh no, Python. That's interesting. All right.
Man, what are they doing with these instances that don't even have Python on it? I feel
I know. Seriously, it's just what? All right, so we were.
Give us a little bit to work with here.
I know, seriously. So, anyways, we are making Urbit right now. So we are. So yeah, this might be an interesting time to talk about. So what are jets? So we'll go through the details of Knock.
I feel like that's cheating a little bit because everything you have is 4-letter words, and jets is actually a 3-letter word. You just pluralized it. So I don't know.
So I should mention too, we're pretty committed to rolling back on a lot of that 4-letter naming. we have a guy right now who's kind of rewriting the whole standard library, basically in this. He's basically almost porting a lot of the Haskell data structures and standard library functions to sort of the Hoon version. So it's like instead of unit for, you'll have like maybe, or instead of like
right,
whatever.
But anyway,
some random 4-letter name. Yeah.
Yeah.
So nonetheless, in Nock, the only arithmetic operator is increment. So of course, increment is fast, but if you wanted to even just like decrement a number, which is the most primitive of like arithmetic operations, you have to increment up to 1 minus a counter. So it's an O of n operation, and then that makes add like O of n squared and so forth. So Nock is not adequately performant at all. So the way to get around this is use Nock as a way to specify you write your functions in Hoon, which they compile to Nock, and that defines the specification for your function. But you can add a little, what we call a hint, which sends a hint to the interpreter. It basically says, if you see this exact Nock structure, or if you see this exact kind of hint, you should actually look in your C interpreter files and see if you have a jet that matches what I'm trying to do right now. Right. And if you do, you should run that super optimized C code instead of what I have right here.
And the idea here is that just if you have increment, that's Turing complete. You can do anything with increment. You can do any arbitrary computation, but it's just slow. So you want to optimize it with these jets that people write to.
Yeah, I mean, Nock is defined as more of a kind of a Maxwell's equations of system software rather than in a way that's still practical from the standpoint of being able to understand it. Like you'd be surprised, and we have a number of people who've done this. They've written real programs in raw Nock, which you never have to do except for just like, it actually really helps you understand the system.
I'm surprised by that, man. I've been to tech conferences where people do stupid, inefficient stuff.
Yeah, I mean, we have a guy who the video you may have checked out last night. He wrote a Goldbach number conjecture theory like disprover in raw Nock, and it's literally just like it's a page of numbers and cells, which is great. Okay, cool. So we have this made. So let's clone Urbit.
I think you already did, but yeah.
Or not Urbit, Arvo. Sorry, we don't have Arvo. So cool. Now you can finally, so instead of when I brew install Urbit, I would just like do Urbit, but because I have a binary in the bin or bind. Do you say bind or bin? I've never known that.
Bin. I say bin.
I say bin. Okay, so whatever. So bin Urbit, and then the command's a little different to boot a planet. It's going to be -w, and
we
then
need the credentials, right? Yeah.
We need the planet name, so ravtic, and without the little
tilde.
Without the little tilde, yeah, which we call, oops, that's not what I wanted to do. Okay, whatever. In Urbit, ravtic, fitzer, t, and then get rid of this. That's right? Yep. That's gonna do this thing. So why don't we talk about what's actually happening right here? So
yeah, sure.
So you'll see we fetch or we curl this pill. So what's a pill? The pill is basically kind of in a lot of ways, it's like an Urbit binary. So it's basically a raw Nock noun, but just a jumble up sort of gibberish of compiled Nock. But that's how, so again, Urbit being a Nock interpreter, you kind of have to bootstrap from something. So you start off with only raw Nock. And in fact, your first event is this big noun, which basically kind of confirms that everything is okay. And then from that, you have within that basically the Hoon compiler in raw Nock. So once you have the Hoon compiler, then you get the compiler as source code over the web, and then you compile the compiler, and then from that you can load in Hoon.Hoon, and then you have the full language.
The Hoon compiler is a pill. That would be the format of it.
Yeah. So that's exactly. just kind of, so in Hoon.Hoon, so Hoon.Hoon is about a 10,000 line file. The compiler is about a third of that, maybe a little less actually.
Right.
Another kind of third to 2/3 is the standard library.
It's making me realize that I don't actually understand how operating systems work.
Yeah, exactly.
You have to rethink like all these things. It's like, how do you get the original compiler? And like, I don't know, like.
Exactly. Yeah, I mean, it's like if
it's really.
We have a great kind of marketing video on this where it's like you think of your Urbit as a child, right? So it's born and it's a baby and it has never like opened its eyes before, and then it gets its first event, which is Hoon, basically.
Right.
And then like and so what's so cool, like just to reiterate, what's so cool about making this virtual machine so simple and aspiringly perfect is that if that never changes basically ever, then everything else above that you can update over the wire. So you can imagine like it'd be so cool if like in 100 years my like great grandkids, right, could take a flash drive of my like digital avatar basically and stick it in and have it run without them even having to think about it. Yeah, it might take a week to like sync up all the events and stuff, but like
it's like Bitcoin or something, right? Like in theory you should be able to bootstrap the network from scratch and just play every transaction from start to finish.
Right. Totally.
Yeah, it's only that, but with the state of a computer, which is actually kind of interesting because isn't that like the idea behind Ethereum is that you want an immutable ledger, but just like of a shared computer state. Instead of just of like a ledger of transactions. It's like you just want the state of a computer, but consensus from that and like, from scratch. So
right, totally.
But this obviously is multiple computers, and you only are trying to agree on the state of, or you only have this immutable ledger of the state of one individual computer, right?
Yeah, I mean, one way to explain Urbit is in a weird way. Urbit's kind of like a personal blockchain. So like,
yeah, exactly. It's like your own instance of Ethereum potentially.
Yeah, so I mean, blockchains, what they're really designed for is consensus mechanisms. But in terms of having the structure of an immutable ledger of facts, or blocks of things that have happened, and that can never change, Urbit is no different. So you have, on the Ethereum blockchain, it's everybody's like big data, right? And Urbit is for your little data. So every message you send, every file you have on there, every app you run, it just lives in your digital avatar, basically.
It's really fascinating, which is why I'm curious. Like, all right, now that we're in the Doja, let's how do you build an application on it? Like, it's got the high concept, right? It's like if you read the movie trailer, you're like, I'd watch this movie. But now, but now it's like, I'm like so curious to see like what the actual dev flow is like.
Totally. So actually, what we do, the current event model is you boot as a comet first, and then you like magically transform into a planet. So you get your first, you get the pill and your first events from Zod, which is it's galaxy number 0. It's kind of the parent galaxy of Urbit. So what's interesting to note is that like for the network to bootstrap itself, the galaxies all have static IP addresses. So this is hard coded into the interpreter and into the system basically. So your Urbit knows where to go look for this stuff originally. And then same with most of the stars. So at least with our stars, they all have static IP addresses. So once you become a neighbor with your star, you register their IP address, in your kind of log of addresses. And then once you basically get somebody's IP address, everything happens peer-to-peer. But so for example, if I wanted to send you a simple direct message, but I didn't have your IP address, because let's just say you're running around on your laptop or something, or maybe Comcast decides to roll over your IP or whatever, then I go ping my star. And if we're both the same children of the same star, then that star will know where you are. But if not, it'll ask its parent galaxy, which it'll find you somehow, and then your IP gets kind of pinged all the way back up and down through the hierarchy back to me.
Is the IP address of the Zod galaxy hard coded into the operating system or something?
Yes.
Yeah. So there is like considered like a boot node. Well, I mean, it's the same even with Ethereum, right? Where it's like, you need to find other Ethereum nodes, but you need to like have some sort of registry hard coded so you can find the first one to begin with.
Yeah,
Or like
totally.
A or like any of these things, right?
Well, what's really cool about Urbit is that so many of these features that are normally like developers are forced to develop these in the application level, such as like peer discovery. Like so much of Bitcoin and Ethereum is just like peer discovery, right? Urbit solves all these things at the operating system level. So you can imagine building a sort of like
that's super
Urbit blockchain, Ethereum type of thing. And as a developer, you just don't even have to worry about, and so, I mean, so many things. It's like the public key infrastructure. It's like identity, authentication, having, talking over HTTP. It's, having an application sandbox. All this stuff is just built in.
Super interesting concept.
Yeah. So we're almost done booting. So we got our first knock sort of compiled bytecode essentially. Then we got Hoon, and then we got the standard library. Then we got Arvo, the operating system, in each of the veins. And then we're getting those from our parent, which is a star called Samzad, which is one of the 4 stars that Urbit.org is that has running right now. So we're kind of finally like finishing up our last like network configuration and basically kind of broadcasting that we're on the network. And then pretty soon we're going to sync in the file system for your Urbit, which has all the apps and all the user space and stuff.
In terms of networking, what is this actually doing? It's register, because this is the first time this planet's ever been booted, I guess. So does it need to like register itself with the host stars, what you're saying? It's like...
So the way Urbit networking works generally is it works over UDP, which means that...
UDP,
it's interesting because the modern internet is built, of course, on TCP and IP.
Yeah.
When you have a system that's built in this sort of event-driven way that's transactional, you can guarantee exactly once delivery of all these network events because you treat these events as if they were, instead of kind of directly sending a command to do something, it's more like on Urbit, you send kind of a log of a fact that something is happened, and it either does register and you get the confirmation back, or it doesn't happen. And so you get the fancy word is idempotent. What's the fancy word? Like idempotent functions, right? Where if you call the same function twice, it's the same effect as if you call it once, right? So
sure, yeah. Pure functions. I think idempotent might be the right word.
I think that's the right word. Yeah. Butchered that pronunciation, but So basically, when so everything is asynchronous in this way. And so if, let's just say you want to ask for a file at any given kind of date with this sort of revision history, well, that's just kind of like a fact that has been emitted into the network, and you can somehow discover that fact either exists, or if it doesn't, for whatever reason, like let's just say you want to ask for the cover of the New York Times a week from now. Well, it's not a week from now. So what do? You just block until a week from now happens, and then magically you will get the front page of the New York Times. And there's some interesting stuff that kind of goes into that.
What hardware is actually running those like master servers? Like, are those just like, do you guys like just have like a giant data center in your office or something?
No, they're just running on GCP, Google Cloud.
So you just have cloud nodes that run these master instances and whatever.
Yeah.
And is that the intention of the Urbit network once it gets ready for like mainstream use? Is that it's just going to be basically it's just going to be cloud instances that people are running on normal consumer hardware, and it's just...
Well, so yeah, we'll ideally we would basically bootstrap a hosting service that runs on top of Google Cloud or AWS or whatever, and we would people would trust us that we're going to kind of nobly host their Urbits, and there's a lot of kind of privacy details with that and stuff, which is actually there's more heart of a line with general purpose computing rather than sort of special case web apps and UIs. So it's like with, take Facebook, right? Like you want to say, well, yeah, Facebook should be able to track my data and stuff. But actually like the line is very blurred because the service itself is literally managing your data because they are a server, they're a mainframe that, hosts your profile, right? Your profile is just a row in the database. So the line is very blurred. Whereas with general purpose computing, the classic example is like, Netflix and Amazon are their two biggest competitors with each other, but all of Netflix's infrastructure runs on AWS, right? So why doesn't AWS just kind of like just spy on Netflix and get some training data or whatever? Well, there's a very clear line between like breaking into somebody's general purpose kind of server. It's a very hard line basically. So you can establish very clear like terms of service and privacy guidelines where like we can't just go tap into anybody's Urbit arbitrarily.
I wouldn't do that, and I would be skeptical of the claim that they don't even.
Yeah, exactly.
I don't know where we're going with that, but when one company has so much infrastructure and they have business motives and all that kind of stuff, But anyway, okay, cool. We're in the dojo.
Okay, sweet. So we're in the dojo. So
we made it.
We made it. Okay, so let's do this thing. One thing that is helpful, just to kind of finish this up, is like, so we didn't go about this when we were in the comment, but there's actually two main apps running in Urbit right now. So there's Dojo, which is this REPL in the shell. Right. But then by hitting Control X on my keyboard, I can toggle back and forth. And this is Talk. So Talk is the kind of main app of Urbit right now. It's the most complete app we have so far. And it acts as our sort of decentralized messaging system, which we have a UI that's sort of like a decentralized Slack meets like Discord type of thing. But what's really cool, and this is going to get into our Twitter clone, is that Talk is just a backend that you can use as sort of messaging API. You can use it as a message bus for any kind of message delivery and subscription system.
So can you message? So you can. I'm assuming
we're on the live network right now.
What's up?
So let's do this right now. So let's just join.
Yeah, so I'm assuming you can message a specific. Well, so my first question is going to be: can you message a specific planet, like a DM?
Yes. Yeah. So
but then you could also join a shared chat room, is what you're also saying.
Yeah. So let's read these messages actually. So when you boot Talk, you actually boot with two what we call stations. So and this public station is actually how we'll bootstrap the Twitter clone in a little while. But basically, there are different kinds. We have 4 different kinds of stations. So there's a channel, which is kind of public or normal sort of public channel. There's an inbox, which is publicly writable, but only your Urbit can read it. The opposite of that is a journal, where anybody can read it, but only you can write to it. And then there are kind of invite-only, like we call them villages. So like a private Slack or company chat or something. So you boot with your porch, which is a mailbox, and that kind of acts as your default like inbox. So when you send somebody a direct message, you're actually sending a message to that ship's porch. And the reason, like, they're able to, that the message was in fact sent to them, because when you send this message in the first place, you're encrypting the message at the network level with you're signing the public keys of the ships that are being directed to.
Can you send a message to the comment we had earlier on your local machine?
Yeah, totally.
Can you actually see that happen? That would be
totally. So,
yeah.
Urbit.
Because this should boot in 1 second, right? Yeah, exactly.
Yep. So if I just take this, buddy, and then just pasting this in. Cool. So now I just switched my audience to this comment.
Okay. Oh, interesting. So it got pinged of an event and it downloaded. Okay. So, okay. let me ask you something. So how is the encryption, like, are these messages are encrypted that are going?
Yeah, they're encrypted and authenticated exactly once delivered, all kinds of cool stuff. By default, that's just automatic.
So do you envision, well, I guess, so the problem, I guess, is that you can't get these things anonymously, these planets, right? Because you had to have your email address.
Yeah, so you can boot a comment anonymously. You just go from source. And so that's kind of like, if you wanted to have the sort of like Twitter troll net of Urbit, they'll probably all use comments, because why wouldn't they, right?
Right, so you could just filter out against that, and that's like...
Yeah, but I mean, like, you can make the argument that, like, yeah, there's serious downsides to that, but there's also, I don't know, there's sometimes some interesting media when...
Man.
You're not sort of held accountable.
So are people
but that's a very unique
Are people actively chatting on this right now?
Yeah. So
Like,
I mean, we haven't joined the chat station. So let's
well, yeah, but I mean, like, just like, what's the usage like of just because I mean, like, it's like a kind of weird workflow, but like anonymous encrypted chat using like this kind of funny workflow is actually kind of interesting. Like,
yeah. Well, there's kind of interestingly, there's I mean, it's not intentional, of course. Like we're in a beta and we want to make this usable to like normal people, but nonetheless, like at the current stage, there is kind of a barrier to entry. It's sort of like maybe not strictly programmers, but just like generally sort of smart, tech savvy people. So for all we know, there could be like kind of like private little circles happening independent of what we're doing. And that's actually what we want. Like that's the reason we're building the system.
Yeah.
We want these sort of sub communities to exist independently of each other. Whereas like today, everybody's on Twitter or everybody's on Facebook, and it's the same UI. You get shown the same ads. You get the same trending topics. Right. There's no kind of like as much of the conversation of like sort of cultural differentiation, like diversity. Like it'd be great if you could actually build social infrastructure that enabled that by allowing people to have their own independent communities.
You're preaching to the choir there.
Or I don't know. I mean, that's the hope, right? So let's join.
I've got my put options on Facebook and Twitter, betting on lies. So
exactly. Yeah. So we're going to join Urbit Meta, which is kind of the main like public channel right now, which we host on our stars. They're federated between the 4 stars right now are Marzod, Binzod, Samzod, and OneZod.
What does that mean, federated, by the way? Because I always see that word with like these, and I've never actually known what it meant.
Yeah, so a classic example is like if you're playing tic-tac-toe. Right? So if you were playing centralized tic-tac-toe on tictactoe.com, it's easy, right? As a developer for that website, you're just storing the game state in a data structure on your server, right? And then you're displaying that UI to some people, and the developers kind of own the server. It's on one server, right? So it's easy to manage. But when you have multiple computers at play, and you have distributed systems, you need a way to synchronize this state, right? So it's like when I update my move, I need to send, a typed and authenticated message over some network, right? Which literally transfers over wires and stuff to some other computer, and those have to register. And so it gets, almost, exponentially more complicated. But Urbit solves a lot of these problems where, like in the case of talk, it's just the way we built sort of the application interface and the way to synchronize state is really simple. So with talk, like we have the kind of main Urbit Meta station running on one star, and then you can federate that with another star, so that basically when of course all these stars have their own planet children. It's funny, just like the terminology, it gets insane. But like when planet of one star like sends a message to that star, it should go to everybody else, right? And so there should be kind of a global sort of synced state of like the Urbit Meta chat room. So that's all the federation means. So you're synchronizing state across computers.
When you started this up, did you download every message that's ever been posted in this chat room forever?
No, I downloaded, I think by default we download the messages of the last like 2 days or something.
Gotcha. Yeah, I was going to say, because like I don't know like what the issues with scalability are with Urbit.
Yeah, no, exactly.
With like this immutable ledger stuff, it always is an issue. So
yeah, so when you have sort of this immutable persistent event history of your Urbit, as you can imagine, like that can grow pretty quickly. So there are of course ways to quote unquote prune your event log, and then you mark a checkpoint. So if you trusted that, and if you had a sequence of checkpoints, if you trusted that there was a clear path from here to here, and you didn't really care about the stuff in the middle, well, then you could just, prune those and, treat it as if it was a single jump, like a single diff, basically.
Right. Okay, cool. So we're in a shared chat room, yeah?
Yeah, so people are talking right now. So we have a talk bot, actually. So then, if I could actually join on here. So joining on comment's a little different because as a planet, by default, you join the station on your parent star, but comments don't have stars as parents, so you have to specify the star. So like Marzod, Samzod, OneZod, or Binzod? Which one?
Oh, which star do you want to use?
Yeah, I'm just asking you for fun.
I don't know, man. Marzad is
All
fine.
right, Marzad. Sorry.
another trivia.
Yeah, exactly. I was keeping you on your feet.
So he's going to need to download a lot of stuff. Didn't look like he did, though.
Well, he's syncing this over Ames, which is the network, and then it's going to take a second, and then he's going to go and download all the messages. So then, sure enough, when I sync this thing, I should get what's up in my last message.
Yeah. So it's going to sync like 700 messages or something.
And there we go.
So anyone that has a planet could create whatever channel they want and just start using it right now.
Yep.
Yeah. Okay.
Yeah, and people do. So like we have like a bar. There's this guy. His planet name is Bar Pub. So he runs like the watering hole, like the
Bar Pub. Yeah.
He runs the bar, which is great. So that's a fun place to hang out.
Yeah, it's kind of interesting. Like I'm gonna dive into it, but I'm curious about the little community that's actually using this. It should be probably interesting people. So
yeah, we have a talk bot, which is kind of cool.
Cool. Yep, I got it. All right, very cool. Very cool.
You can get inspirational quotes if you want.
Yeah, hit me with one. All right, cool, man. All right, cool. So that's Talk is this chat server.
So why don't we,
or just messaging.
We should point out, like, I mean, we haven't left the console yet, so
right,
we should.
Still in Dojo, yeah.
Urbit has a web interface, so like we should check this out actually. So what's really cool.
So do you mean my planet has a web UI? Like there's
yeah. So if I go by ls my desk, you'll see that we have this web folder, which is kind of the equivalent of like if you're hosting a public internet server like Apache, you'll have like public HTML or something.
Yep.
It's kind of the equivalent.
Yep.
So you're serving
index.html in there. There should be.
Yeah. So we have it's a little bit different. So if we go ls/web, we'll see.
A little bit different.
It's a little bit different. So actually, this thing, it's a little different with how the mark system, which we'll get into later, is kind of like the type system, the operation. The operating system level, how that works. But anyways, it's like web.md is the equivalent of index.html for us.
Yeah.
Web. So we have a.
Yeah, I want to see RavTick PidServe, man. We've got a planet. We have a UI to our planet. This is just this is just stuff, man.
Yeah. So I mean, it's great. It's like you don't have to. Sort of similar to like whatever GitHub pages or
it's
you just get a DNS hooked up already. It takes a little bit. Like your let's shut down our comment. I don't think we need this anymore. Cool.
Yeah, you can get rid of that.
So we'll go over a little hack to make this faster, actually. But so the reason this is happening over Ames and not over HTTP is because Urbit.org. So we're proxying. We have an Nginx cache that's proxying via Marzad, and Marzad is polling the data on your ship, which is hosted on Clay, which is the global file system, to the star, and then that's what's getting served to the web.
So when you say Ames uses UDP for internet traffic, and that's communicating with Marzad, which is a computer that Tlon is running on just DigitalOcean or whatever.
Yes.
And then what is this file system you were saying? Clay?
Clay is the global file system. It's like
what is that?
It's like Git meets Finder meets Dropbox, sort of. Like it's like if you had Dropbox level storage that kind of synced automatically and propagated everywhere, but then you also had a sort of a typed revision control system.
But when you say global file system, like, so you mean just on the star? The star has some sort of file system that...
No, so what I mean is that because the your name of your Urbit identity is just a number that's kind of pre-programmatically generated.
Yeah.
Every file on the whole Urbit network has an independent path, basically.
Mm-hmm.
So a full Clay path, actually, which actually you're kind of seeing this sort of right here.
Yeah.
Highlighting. So a full Clay path is ship, desk, which is kind of like, there's sort of like branches essentially. So you can think of it like identity, branch, case is like the version control number. You can also have labels. You can label by date, etc. And then there's kind of a, whatever path you want after that. So in other words, I can fetch. Of course, like we don't have this built in the system yet, but at some point we'll have like access controls. So like, of course, not everything should be public. But for now, I can basically pull any file out of your file system and load it up basically, because everything has an immutable path.
Yeah,
and that never changes. Yeah.
If you knew the path to a file on my file system, you could view it.
Yeah. So of course, like we'll have access controls at some point. Right. That's important. Gotcha. But yeah, for now, that's how that works. So we actually have that's a good example of we have an API connector to block.io that a buddy of ours made. So you can actually send Bitcoin and Dogecoin and stuff with your Urbit now through it's through an API. You're not doing it from your Urbit directly, but you store in actually we'll see. Oh, it's timed out. It'll load up in a sec. On your kind of profile page, you'll store sort of like a Keaton
when you're saying urbit.org, that is like looking at this file system directly. So this computer, just by the fact that we are like logged into the dojo, means it's running that web server UI by default.
Yes.
Yeah, gotcha. Okay, that makes sense.
Yeah.
But it's not like serving this response out of a cache. It's literally reading off the file system.
Yeah, so we have a caching mechanism.
I get it now. Yeah, that makes sense.
That's actually like literally kind of our biggest project right now is totally revamping the Ford, which is the build system, like that caching system, and making it like seriously faster. Also, like, so there is kind of this is a very weird system. Like if I want to have something on my personal server displaying on the public internet, I have to go through like some star that Tlon owns. It's not very like practical. It's just kind of a hack that works. So what actually should happen is you should be able to just basically self-generate your own secure like SSL certificate and host this on your ship. And then you should be able to point, shipname.urbit.org to the IP address of your planet in this case, and the star, instead of the star like Marzod, actually fetching the files and hosting them directly at that URL. Instead, Marzod will just hold an index of all the public IP addresses of its children. And then if you want to look up, rafts like PidCert, you would just ask Marzod for that IP, and then the DNS would resolve to the IP of the planet. So it's why it's important that you have a static IP address, because if that never changes, then the caching is faster, all this stuff. So actually, we could demonstrate that.
Okay, wait. I was going to say, so we have the UI up. Yeah, I thought it worked just by looking at the command messages. But yeah, so the UI is up.
Yeah. One sec. I just want to grab this real quick.
Oh yeah, sure.
Other window. So this is our UI, which is kind of cool, right? It's sort of hyper minimalist, and like you said, you like their black and white aesthetics.
Well, I know, because I'm going with black and white for Decypher. So we're the colorless bros over here.
Exactly.
Raptic is there. Huh, fascinating. So
when we log in,
any planet will just have like some, and you can modify this, right? If you just change that markdown file.
Yeah. So, and people have done this.
Like people have some creativity, like little UI thingies here.
Yeah, totally. I have a cookie set for my planet. So let's run this on incognito mode. Oops, that's not what I wanted. Have to consider .org. That's faster. And then I log in. And then it's going to ask me for, it says type plus code, or less code, we say in Urbit, in your dojo for your passcode. So if I go so if I literally just type plus code, copy this in, it's going to authenticate. And then I'm logged in. And then, so that authentication mechanism happens through, we have a web API that we load in, and we can kind of go into the details of that a little bit, how that works. But yeah, so I can actually edit this file.
Yep.
Are
you looking for a motivational quote to put?
Something like that.
Yeah.
That'll be boring.
I was trying to think of one. But this is literally just writing to a file on your file system, right? This isn't in a database. This is just overwriting your file system.
Yeah, so what you'll see actually is, so we just got a notification that we just generated a what's called your plan file. So now if we cat this, let's just take this whole path. Oops. Well,
yeah, just cat it. That's fine.
And paste that in. We should see that. Takes a sec. Oh, it's funny. So this is the nounified version of our file, but we can load this up in our editor. So let's see. We'll run the cloud. So
yeah, you need a remote Atom. I don't know if you've ever used that plugin, but it lets you lets you use Atom for easy, like whatever cloud files.
Yeah.
You can just use Vim, it's fine.
All right, so
you can just use Vim.
So we have to mount this to our file system. So we do this. We say this is basically a command that says mount the current desk to Unix. So now, if I do this again, I should have a home desk. So then this is basically just a copy of my operating system. So then I can cat home/web.plan, and then sure enough, yeah, it shows me that I'm Keaton and my location is SF. If that makes sense. So it's just, and then we have a special system for reading that file and then displaying this to the web.
It slightly makes sense, but it's cool. Like it's not the kind of thing I'm gonna wrap my head around immediately, like how this whole interaction works. Like
totally.
Yeah, but anyway.
So then, well, one thing to point out is that so basically what I hinted at earlier is that Urbit.org is slow right now. So the way you get around this is I have the IP address from this. It's a static IP that I'm running my plan on, and then your Urbit is serving over port 8080. I think. So I'm not sure if I have this firewall or not. Let's see if this works. Yeah, it works. So yeah, it's way faster. So then if I do the same, so a shorthand for login is this, you'll see this tilde, or we call it sig in the URL. And that basically says, if I'm not authenticated, then redirect me to the sign-in page.
Yeah.
Let me get that password again. And then, okay, yeah, we actually want to get building stuff, so we'll move a little quicker. So I think all I wanted to point out was like, so yeah, you have this web interface, which is cool. The cool thing about Clay, the file system, is that, so it's saying that, okay, we're serving this web plan file from the second revision, but if I take this path and change the revision number to 1, which is the first revision.
Yeah, you probably need to get rid of a dash there, yeah. Yep, it should be.
There actually isn't a. This might work. Maybe not. Oh, right, because I have to do web.
Oh, right. So the default one you're saying isn't 1; it's just 0. Yeah.
Actually, it's because. Yeah, there we go. So first version of your home directory doesn't have this.
Yeah.
The second
and then version 2 does.
Version 2 does. So like.
And then when you did 0, that's just getting the current one, basically.
Yeah. This is 0. So then like one shorthand that we have is like, instead of like full ship, full desk, full like case, if you just do so an equal sign or tis is like the default ship is my ship. The default desk is like the current desk that I'm serving to the web. And then the current case is like the latest date. So if I just did this, that's basically the same thing.
Gotcha. Yep. Okay.
These are kind of minor details. So anyways, if we want to go, so talk is really fast. Here's the web interface for talk. And then we'll use this quickly to kind of bootstrap our sort of Twitter clone thing. So it's kind of minimalist.
That's the Urbit meta chat room that we were in, right?
Yeah, this is Urbit meta. So we had our inspirational quote, and we talked to TalkBot, and then some people were talking about interesting stuff above here, and sending Dogecoin, which is a little chaotic, but it doesn't work. So This is all kind of funny beta stuff. So then another place to come hang out is Fora, which is kind of a public forum. And I'm already authenticated, so going to SigSig will make it so that when I'm making a post, I'm posting it as my plant name. So then eventually you build up like a reputation, which is kind of cool in the community.
All right, yeah, makes sense.
A second. Yeah, so we're gonna load that. And then the thing I actually want to show off is, so then you visit the docs the same way, and these would load. But as you can see, like Urbit is kind of slow right now. So actually what we should do is we should sync the docs over the network, and then we can host the docs locally from our own file system. And that kind of goes in the same mind as like your personal server. You should talk to your server directly, not go somewhere else for stuff. So there's a command we can do for this. So we want to sync to our home desk, which is our default desk. There's an examples planet right now.
And you said a desk is like a branch in Git, kind of.
Yeah. So this is sort of an equivalent of like Git clone, but the difference is, so Git has pull semantics, whereas Clay and Urbit has push semantics. So like when you sync to a desk, you'll actually continuously get updates automatically. You don't have to constantly like pull for changes.
Gotcha. Yeah.
You can, I mean, of course, you can just like straight merge a desk and you won't stay synchronized. But if you do want to stay synchronized, this is the way to do it.
Okay.
So cool. This planet, Ratmev Pakseb is my neighbor. I'm syncing the docs desk, downloading this over AIMS. It's going to take a minute.
What is that is your neighbor thing that I keep seeing?
It basically just means like you've talked to this Urbit identity for the first time.
So not like geographically your neighbor, but like conceptually your neighbor.
Exactly.
Is there any concept of geography here? Like, or is each planet completely indistinguishable from another planet? Like there's no concept of like your like physical neighbor as a planet or something, like something that has a closer number to you, or I guess someone could create that construction if they wanted to.
Yeah, I mean, it'd be really cool to sort of visualize the Urbit network somehow.
Well, if you have numbers, right, you probably could. So
yeah, I mean, it's just like,
yeah,
I mean, it's a tree basically, right? It's a hierarchy in that sense.
Yeah, cool. All right.
But anyways, this is thinking. So then once we get this, we'll do the docs. But I think what we really wanted to do is let's get building stuff, because I feel like we could talk about this stuff forever. It's just funny. There's just so much stuff to go over because it's a new system.
It's like once I realized that it's something that's supposed to be an alternative to Linux, I'm like, oh yeah, this is going to take forever, because Linux you could talk about forever in and of itself, and now that's something people actually already even understand. So,
yeah, seriously.
So we're going real down the rabbit hole here.
Exactly.
I mean, I have a lot of like high level questions, but I guess while we're waiting for sync, so what do you actually envision like this being used for practically? Like, what do you think people are going to start using Urbit for? Like, what's your hope that like people will start doing kind of soon on Urbit?
Yeah, it's a good question. In the near term, I think Urbit is a great place for, I mean, simple tools, even just like, I mean, Talk is a great example. Like messaging, it really isn't as much of a solved problem as you think it is. I mean, you have, of course, things like Facebook Messenger, WhatsApp, and blah, blah, blah. But like, actually, the point of that is all these things are siloed off. You know, they're in the trust of a third party. But then there's also like, there's kind of decentralized chat mechanisms that like sort of work, but they're also technically complicated. Like there isn't just a simple encrypted decentralized chat that I own on my personal server. It just works.
Have you looked into Matrix at all? That's something I've just been reading.
We have, yeah, a little bit. I don't know too much of the details, but
I don't know either. I just know that like people are starting to use it because they're saying exactly what you said. They're just like, oh, so gotcha. So now this is being run from our local planet, just being hosted.
Exactly.
Yeah.
So then I can access this from my phone. I can log in and talk. I can do all this stuff. Of course, at some point we'll have sort of a mobile app, which pings you notifications and stuff, and that'll be complete. But for now, it's kind of the early alpha stage. So nonetheless, like if you want to, we basically went through most of these. Want to learn Hoon, this is the place to come. So we want to get something running. So actually what we need to do, the next desk we need to sync is the examples desk. And so we're going to create our own copy basically. And this is on the same ship. So this isn't going to sync to our home desk. It's going to kind of keep them separate. So it's sort of like a sandbox. And then when we do this, we'll be able to have kind of our example of the Twitter clone, an example of just the simple hello world, and we can kind of walk through those.
Okay. Yeah, let's do it.
So this will take a quick bit.
So
let's see.
You know what you guys should do is like the way that Tezos did it, where because like there is a lot to wrap your head around with this. But like with Tezos, they raised like, like whatever it was, like $200-something million. And then they just put 50 million aside to just fund, like they're literally just going to pay people to build stuff in Tezos or like learn about Tezos. It's like,
right.
You're a really smart developer. You have a cool idea. We'll pay you like millions of dollars to do this in Tezos instead of something else. So like it'd be cool if Urbit could like do that where they're like, we'll just pay developers to build things on Urbit, like, and literally just pay them to do it.
Yeah, totally. It's a good idea.
Yeah.
One thing to keep in mind is that there isn't really a cost, as you would think conventionally, to developing on Urbit, because the user takes on the expense of hosting the application or the library or whatever. So normally it's like, let's just say I wanted to build kind of my own rendition of like Snapchat or Instagram, right? And you can think of a lot of really cool like potential UIs. You have infinite combinations of these UIs. Like imagine if you had, it's like Twitter, but you can only have like, more than 500 words and you can only respond after 24 hours and like you have to use your real name or something.
You wanted to tweak the Twitter parameters or something.
Yeah, just kind of arbitrarily to make some cool UIs. I mean, Vine was a great example of that. Just by limiting the videos to 6 seconds, you got some really cool media, right? So to do that in today's world, you have to go build a startup that competes with Facebook and Twitter, and you have to generate revenue to pay for the cost of your infrastructure and stuff. In an urban world, you can build this in a weekend and just deploy it, and if people like it and it takes off, of course, there are ways to monetize stuff through. Eventually, we'll have things like micropayments and sort of paywall type of stuff. But generally speaking, the reason most developers develop is because it's fun, right? And in a lot of ways, if you think back to like the early days of the internet, nobody was really thinking about making this insane amounts of cash that people make today. It was just because it was fun, and a way to connect to people and be social. That's not like the best answer, in terms of like our economic strategy. There needs to be like commercially viable business opportunities for developers on Urbit. But generally speaking, it's like you can either, help people make money or you can help people lower costs. And we definitely help lower costs a lot.
That's dude, trust me, that's one of the things about Ethereum that's super interesting to me is just the like little overhead required to build a large scale system and the potential economic incentives for doing it. Like you could build a Twitter on Ethereum and just deploy it and not have to, really manage any of the overhead except maybe one like web client or something.
Right. Totally.
Yeah. And it's like, just use that as a back end and like potentially even make money from it if you do the economics right. So that's really fascinating to me. And like, I'm 100% in that's where we're going. Like I'm very short Twitter and Facebook right now. So like,
so cool. So we have these examples now. So the equivalent of like CD in a Unix prompt is equals dir. So we're just setting our directory to the examples desk.
Okay, cool.
So that changes our prompt.
Equal dir is your CD command. Got it.
Basically, this is kind of annoying.
All right, yeah, and just so we didn't lose the train of thought because we had to wait a minute for that to sync, this examples directory came from another planet. So you basically like downloaded an examples directory from another planet, and that's just like whatever copying files from one computer to another kind of thing.
Exactly.
Yeah.
Exactly. Okay. Right now,
default, is everything on every planet copyable, or like you have to whitelist things?
Yeah, you can.
Gotcha.
You can copy everything.
Gotcha. Okay, cool.
Well, again, I have like permissions and stuff later, but for now, that's the case. So we're still serving our home directory to the web. So if we want to get these examples things in the web, we have to do this command serve, and then our current directory. So the %, which we call sen, is kind of like dot in Unix. So you can do like dot is like two directories back. Dot is like the current directory or the current desk in this case. So you can go serve the current desk, which is examples, and then you want to serve the web directory.
Right.
So we're going to run this. Great. So now we're serving this. And then lastly, we want also mount this to Unix. I guess I should go back to the, so this is going to take a second. And then when that's done, I should have a examples desk, and we can kind of look at the code. Well, so now I'm serving this to the web. So the examples desk also has the docs in here. So that's cool. Just like when you need help to look at stuff. But then you can go to, just examples. We'll get this to work. At least it should. For some reason, it's hiccuping on this. We did add a lot of files recently, but I don't think that should change anything. There we go. Okay, so now if I else this, now I have an examples desk. So, so this is where we have our like Twitter clone. We have kind of a little hello world, which we get running.
All right. So in this examples folder, one of these things is a Twitter clone, is what you're saying.
So yeah. So let's kind of go over the structure of Arvo, the operating system generally. So apps are Gall apps. Remember, Gall is the kernel module or the vein for the application sandbox of Urbit. So in that app is where you define like your app state, how you're storing that, what kind of state changes you can make, the functions that allow that, the kind of subscriptions you can make, how these propagate to other subscribers. And we'll go into the details of that.
So an application has kind of a structure on Urbit.
Yes, very much so.
It's not just like open, like Turing complete programming language, make whatever you want.
No, it's like very kind
of
opinionated and like this is the way to do it or else
okay,
it
cool.
won't work.
That makes sense, yeah.
Gen are generators. So like when we did like ls, that's a generator.
Right.
Oops. All right. Just gonna do this. Cool. So yeah, so here's app. So we have like, these are all the examples. So we have like, the block.io is like the Bitcoin payment thing. We've got the bunch of cool test apps. We got a TalkBot. Tumblr without ads, which is kind of cool.
So let's see twit.hoon.
I think.
Oh, this is gonna be actual code.
All right.
Yeah, so this is Hoon code, right? We've looked at this before and it's fucking crazy, but apparently not as crazy as you think. But yeah.
Yeah, exactly.
But anyway, so this Hoon code is doing what?
Well,
you can open this in Vim if it's easier.
Let's not go there yet. Let's stay on kind of like the front end side of things.
Okay.
And then we'll kind of bring it back. So that's app. Gen, there's generators there. So you have like, Project Euler generators. So you can be like, or even just like a hello. So you can go like, hello / like page one, and then like world. That should be hello. Okay, cool. So it's just kind of like a functional, script. So something like this, that's like the dumbest of all human programs, basically.
Right.
But anyways, so then you have generators, you have libraries. So we have some of these are examples. Some of these are actually used by Arvo itself. So there's like authentication libraries, there's string processing libraries. There's a library for writing the file system. There's a Gmail library. Basically, libraries are like, common functions that you want to use between different apps, right? So like Gmail is a good example. You might want to have, different UIs or different apps that, as a side effect, send out an API call to send an email through your Gmail. So that should be abstracted out, and a library can use in multiple places, basically.
So the thing that these Hoon programs really are kind of just like connectors to backend APIs. So like the Gmail.Hoon would just be like the API for sending emails, and you can build whatever UI around it that you wanted to, kind of thing. Yeah,
like the Curtis talks about this a lot. Who's the original founder, for those of you who don't know watching. So yeah, he talks a lot about how like computers really since their like inception were mostly defined in terms of their capacity for I/O, input output, right? So in the early days it was kind of terminal and that sort of advanced. And in an urban world, you can imagine the sort of fundamental I/O like core as web APIs. It's like packets come in, packets come out, and your Urbit is kind of in the middle of that, sort of organizing all of your stuff.
Wow, that is kind of interesting to think about, like a computer, like you put a USB drive into it and that's the IO, but like when you just eliminate that entire like hardware construction, it's just web APIs are your only IO. Yeah, that's interesting.
Yeah, I mean, you could imagine an architecture where you plugged in like, an Ethernet cable, and that was like the only cable you needed, right? Like that was like your packets that drove the computer.
You don't put an NVIDIA graphics card into this thing. You just
exactly. It's all just packets, basically. Which arguably we're getting there with like on a USB-C or whatever, but that's a different conversation.
Fascinating. That's a cool analogy. All right.
Yeah. So marks. So marks are basically, and we'll get into how sort of the type system of the Hoon language works, but marks are basically types at the operating system level. So what that means is like everything at the end of the day compiles down to a raw knock noun, which is kind of unintelligible unless you had the mark system. So basically when you send a noun over the wire to another Urbit, you specify that you're claiming that this value is of like this mark basically. And that mark corresponds to a file, literally, which contains Hoon code, and the receiving ship, or you can use the mark system on your own ship, and that happens all the time. Like you'll basically run this file over the raw noun, and if it like works and produces the right thing, then it's like, great, I got the right thing. But it's just a way to kind of make sure that you're not sending, you claim that you're sending somebody like a tweet, but actually you're sending them like a malicious virus or something, right? You want to be a way to kind of like thoroughly check that stuff, because the web is a scary place, potentially. But hopefully Urbit is friendly because of how we're designing it. So then,
okay.
Ren,
so we're still on this like tour of Arvo. We're not like actually trying to build something right here, right?
Yeah. So we're basically, so we have this loaded. It's kind of important to understand this stuff so that we can understand what like actually building something means, I guess. So like we're almost done, and then we'll look at kind of the hello world example, and we'll see like where the files actually are and how this thing gets made up. So Ren are actually just like rendered files. We use that for like rendering stuff to the web. It's actually not super important. Seek or SEC are like security drivers for like, again, talking to your APIs and stuff, but we also don't use it right now. SIR is pretty important. SIR is where you define general data structures. So SIR and lib are kind of the same. So lib is where you want shared code. SIR is where you want shared like data structure definitions, or molds as we call them. And we'll go into that later. So it's like if you want to use the same type of, this is what a tweet actually is, like the definition, and you want to share that between like the app file and the mark file and like the web file, and you want that to live in a single place, basically. And then web, of course, is where all the web files get hosted. One thing that is cool, which we can kind of go into actually, is we have our own sort of like, sort of similar to JSX, but like on steroids, our own Hoon markup for XML, which we call sail. So you can write essentially HTML in Hoon, and that has the full like power of a full Turing complete programming language and the whole operating system at your disposal. So you can use like Ford, which is the build system, to load in different files and build or compose a very kind of sophisticated web page that ultimately gets pumped out to HTML.
So the UI template that we would use for this Twitter clone would be in Sail.
Yeah. So let's look this up. So actually, let's go. So here are kind of so these are sort of the readmes, but then we have actually, no, sorry, they're in pages. So let's cat pages /hello.hoon. Actually, let's bin that. Cool. No syntax hiding because I just booted this, but whatever. It's fine. So you can kind of see if you squint closely, you can kind of see
it
like
looks like Hamel or something.
It's like Jade if you ever use Jade, or it's now
exactly. Or Hamel is the Ruby equivalent of Jade, but Jade in JavaScript. That's what this looks like anyway.
Yeah. So it's like so this syntax at the top. This means we're just enabling debugging. This means this whole like value, which is just a Hoon expression. We want to quote unquote cast this to this data type, this happens to be something that's defined in Zeus, which is the Urbit standard library. It's basically the definition of like a XML structure using Sail. So we just want to like, and so like if we format this incorrectly somehow, like we miss a semicolon or we add an extra parentheses or something, then the build system forward will run this and be like, hey, actually this doesn't compute to this thing, and it'll give you an error, and it'll give you a line where this thing occurred.
This is what did you say this was? This was the like it just like says hello and poke me. It has like a thing that says
yes, let's do this. So
can you run this thing?
We're gonna bar start hello. And this is gonna start your app.
So this is an Urbit app, this thing called hello.
Yeah.
And that is just a structured web app. Like these are all web apps.
Essentially, they don't have to be web apps. They could be just raw console apps. But yeah, so what happens is you have. Let's just look at.
I guess my question is, because this is just an HTML page, how does it know to run this as like a web, like serve it? Because the web server just reads off the file system. This is all that you need, basically.
Yeah. So we. Basically, what happens is so we write this HTML file in Sail. When we try to access this path, forward, the build system has a conversion mechanism using the mark system, which again are kind of the type definitions of conversions, to basically convert this whole thing, or compile it essentially into HTML. And that'll just happen automatically.
Why? Or it like pre-compiles it somehow?
Sort of on the fly. It's like when you access this thing, I think there is like a caching mechanism, but when you access this thing,
but it's the app that knows how to compile it. It's like it's not
the app. It's like it's kind of it's a separate. These things are kind of like independent of each other. So like the app logic, like the code you actually write to run your app, is sort of separate from the logic of like.
I'm just trying to get at like what specifically an app is, like where the boundary starts and finishes for what an Urbit app is.
Right. So let's just look at the page, and then we'll kind of see what's going on. So this is just, let's load up the JavaScript console.
My God.
It's just super dumb, but yeah, we got a hello world.
Poke it.
Console. Well, so we said, okay, we subscribed from the web, we peered from the web, and we poked it, and we poked it. So like our Urbit got confirmation of that. So let's kind of start from the JavaScript, and then we'll work our way to the Hoon, I think is the right way to do this.
Okay.
So this is the HTML file or the Sail file. We load in Urb.js is the main kind of web API for Urbit to talk to Urbit through the web, and we'll look at that. And then we run just kind of like a simple hello.js. That's kind of our main app, essentially. So if we go, let's see, ls, let's see, pages, and then we ls hello. So in hello, there's a hello.js. So
right.
Cool. Oh, hey, syntax highlight. It's amazing.
Good job,
so,
getting that.
Exactly. Seriously. So all this is, there's only two. There's only
reading off URB from the window. So like if you went to your console, could you just go back to your console and just type in URB? Yeah. What's on that object?
So interesting stuff, right? So this is what happens when you authenticate.
It's when you log in.
Yeah. So you'll see in this path for Urbit.js, not only do we do this sig thing, which means we want to redirect us if we're not authenticated, we also do this thing, which is sig at, which basically means we want to inject authentication data in an object at the top of this JavaScript file when we load it to the page. And this is done by Ford, the build system. So you talk to your Urbit through Air, which is the web server. Air sees this and is like, hey, I need Ford. This tells me like Ford needs to do something. So then ask Ford, hey, do this, put this authentication data at the top of this file and return to me when you're done. And then Ford does its thing, returns it back to Air. Air's like, great, I have this thing. Now I'm going to serve that back to the web. And then when you view this from browser, you'll see at the very top is this var herb, which contains all this authentication stuff. So let's make this a little bit bigger. I'm not sure. Can you make the font bigger on this? A little bit, yeah. Cool. So your Oryx is just a CSRF token, so that helps with authentication. It's just a long PAT-P, or kind of, it's the same format as like a long comment name, just 128 bits of entropy, basically. I know that I'm a user because I'm authenticated. Here's my parent, Samzad the star, which is kind of useful sometimes. Here's a hash, XOR is the hash of the CSRF token, also for authentication. And then ship and auth are, yeah, they're just like confirmations. Basically, you're like, you want to make sure that user, ship, and auth are all the same thing. And if that's the case, you're authenticated, and you can send stuff. So this is Urbit.js, like that we're looking at right now, which is it's only 330 lines of JavaScript. So it's actually not that complicated. And most of the stuff actually you don't really use anyway. There's only two main interfaces.
I'd say that might be the shortest JavaScript library I've ever seen.
Exactly. Right. We're going through a process of like, we are going to redesign this API. So this is all pretty subject to change. But generally speaking, the sort of pattern of how you talk to your Urbit.
Yeah, gotcha.
It's like you just talk about HTTP, right? So,
yep, gotcha.
So you talk it over, you make an XML HTTP request, an XHR,
yep.
Right? And you're just, putting or pulling or posting or whatever, or getting from an endpoint that your web server from your personal server is, hosting. So that's all this is all kind of wrapper stuff, or like primitive stuff. What really matters is like, there's really two functions you do that, which is window.urb.send and window.urb.bind. So, and this is kind of the general, this maps it very well to like the Gall application model, which we'll see shortly. So send is pretty simple. Or send, there we go. Send is pretty simple. It's just like, are you familiar with the concept of a command query separation, or CQRS? It's kind of, I think Datomic or Clojure were kind of the systems to make this pretty popular.
Say it again.
Command query separation. The idea is basically
sure. It's like, I mean, like you're basically saying things that are stateful have a different class than things that don't change state. Yeah.
Exactly. So it's like when you read something that should never change anything.
Yeah.
When I make a state change, I shouldn't like arbitrarily kind of subscribe to something. So if you want to make a state change, you have to, send your state change.
Right.
And the parameters that this function takes are, of course, your data, the stuff that you're actually sending, that your app is going to do stuff with. Ship, Apple is short for application, so you're sending the stuff to a particular app. But then the interesting part is you're sending this, you're specifying that has a current mark. So what we'll see in the like Twitter app that we'll get to, for example, is that you send this stuff as JSON to your Urbit, which gets picked up by Air, the web server. But your apps are written in Hue, right? They're not written in JavaScript, so they can't just use JSON. So there needs to be some way to convert JSON into Hue so you can, compute on your Hue code. So that's where the mark system comes in. So you basically, in your mark file, which maybe we can look at an example of example might be, is there a hello mark? There is, cool. So let's look at this. So We'll kind of go line by line through what's happening here. Well, first of all, okay, so this is a forward rune, this FASHEP, as we would call this, which uses kind of the pronounceable like ASCII thing. We're just loading something from the namespace. So FASHEP specifically means we want to load a structure file that's in /sir. So if we actually look, we might be going a little fast, but
yeah.
Basically, so in sir hello to whom, we just define what is a hello world. Well, hello world is a chord, which is a string. So,
right. Yeah, I think the train of thought is, but the way that we got here at least is we were looking at this JavaScript file, just looking at what urb.js was actually doing, and that sent us down this rabbit hole. Yeah. So basically, the sort of sequence of steps that happens is if we go, maybe we should just go back to the JavaScript. How much? So I would ask, how much of this do you think you need to wrap your head around in order to make an app?
I think the thing to keep in mind, and I'm probably doing not the best of a job, but like it always kind of goes back to like the Rich Hickey thing, right? It's like simple versus easy. Like the system is actually, it's really simple in the sense that things are separate and they're complected, right? So, but it's not the easiest thing. It's not like, two commands and I have a thing running.
The most, like, I think like your strategy is like, the most important thing is to understand the entire system, and then building apps is like super straightforward once you have your head wrapped around the entire system.
I mean, I think in some ways there's kind of no avoiding that, because everything does play a part, and you can't really understand the whole thing unless you understand the whole thing. So that's why this video about making a Twitter clone on Urbit is about understanding Urbit and not like writing code right now. It's because you have to understand this like somewhat, right? Somewhat, yeah. So like basically what we're doing when we load this web page is we're saying there's some app state that's stored in a Hoon or a Gall app, and that's Hoon code, and we need some way to deliver that to the browser as JSON. So there needs to be a kind of conversion mechanism for that to happen. Right. So if you're thinking about a Twitter app, like you have a UI that reads JSON from the server and let's just say like it's just one feed of like all tweets. Sure. So like, let's just deconstructing it. How does that JSON get served? Well, you're saying it gets served from a Gall app. And then how does it get served as JSON? It needs to have some module that can convert to JSON. Right, and that's the mark system. So you define a mark that converts your Hoon data or state of your app into JSON. Each tweet is going to get stored as Hoon data structure. Correct. And let's just say it's like what you would think of as a hash map right now. Yes, sure. So it's like an array of hash maps. Like it's just going to be like... It should be a list. Yeah, it should be a list, right? Like so it's like one array of hash maps. And then that'll be stored as Hoon. Although that is actually kind of interesting because like you would think of storing something like this in a database, but you're saying that's not even necessary. You can store it on a file system. Yeah, I mean like the Gall basically acts as the database in this way. Like it just takes care of it for you. All right. So you can store this data on a file system and then you can convert it to JSON. Yeah. So I think just like going through that process would be super helpful. Like of just the what each piece in this thingy does. Right. So like if we could do that. So could we make a UI that shows tweets, but not actually like a way to like make them, and we could just write the raw tweet into the data, like into Hoon or something? Yeah, I mean, we are kind of running out of time a little bit. We could just... I know, yeah. we can always do another part to this too. We got to do a part 2. Yeah. Probably part 3. Like. Yeah, I know. Well, definitely. There again, it's just like there's so much stuff to cover that it is a little tough. But what we can do is like we do have a Twitter clone that's functional that we can load right now, and we can just look at what it's doing. And I think that's great. And then potentially next we could do this again and actually construct it. So I still think it's good because this hello thing is so simple, just to understand the general kind of pattern of what's going on. And then it'll really, if you just trust me, it'll really help with the feed thing. So basically, so let's see. So yeah, basically there's a kind of a clear mapping with the Urbit.js JavaScript API and how Gall apps work, which is that there are specific mechanisms, which are separate mechanisms for changing the state of an app and for simply reading from an app or subscribing on a path at an endpoint, right? So in the case of like Twitter, right, if you wanted to post a tweet, that's a different mechanism from just loading your page of all your tweets. So in the case of this Hello World app, what we actually do, so there's this Urbit.send, which actually
that's this is stateful things, right?
Yeah. So actually, this is just for the button clicking. So actually, that's not even the most important right now. What we do on load, so they're on load. So I call this bind hello. So there's this path which we call /web, and we'll see what is important in a minute. So we want to return the results of calling window.urb.bind, which is the Urbit.js function.
Right.
And that function takes a path, which we specify here. The app that we're sending this request to is the hello app, which we started a few minutes ago. We're sending this as the mark, we want back JSON. So the semantics are a little different here. So this says whatever that is defined in your Hoon app to return when I subscribe to the path web, whatever that is defined as, I want you to give it back to me as JSON. And that's going to use the JSON mark conversion system. If there's callback error, if not, it succeeds. Great. So let's actually look at the Hoon code now. So where am I? So if we go, get a hello from your Urbit on the web and say hello back. So we load hello from the store hello structure, which just says that a hello world is a string or a chord, which in this case, maybe a point of clarification. There are two kinds of like strings, quote unquote, on Urbit. There's the chord, which is something like hi, and there's the tape. And the difference is that chord is a text defined as an atom. So this is actually just a number. It's a textual representation of a number. It's sort of similar to like your player name. Whereas tape is actually a list of characters. So the syntax that I'm using here just says type check that this is in fact the type that I'm specifying here. And if it does, determine the value. Otherwise, it's going to produce an error. So it's a linked list of character H and character I, and then it's null terminated. That's the difference. So just a point of clarification. So hello world is just a simple chord as a number. The important part here, which we can get into a little bit, is so it's funny. Like if we have more time, we could go into more sort of the fundamentals, which would help clear this up. But generally speaking, there's sort of a rough equivalent of an object in Hoon, which is called the core. So a core.
Right. So when you were talking about the string, you were talking about chord, C-O-R-D, right?
Yeah. Sorry. Maybe that's a little.
Yeah. And this is core. C-O-R-E is the object.
Correct. So a core is simply a collection of computable attributes, you could say. It's just a tree of expressions, essentially. And this has a very clear mapping to knock, which we can get to in the part 2 of this video, the series. But nonetheless, this syntax here basically says we want to construct this core, which has many computable attributes. But this core, we want to actually, for each of the sort of arms, so these are called arms within the core. So those are the attributes. We want those to be able to operate on a set of arguments, which we call the sample. So this syntax says we want to construct a door which takes a sample or a set of arguments so that we can do operation stuff on this. And the sample in this case, we'll pause for a second after this, but the sample in this case is kind of your boilerplate app state, which we call the bool. And then we want to store a hello world, which is a chord, which is a string.
Great.
Let's pause for a minute because that was just a lot out there.
I know. I have so many questions, but like I said, I think it's probably good to just like acknowledge we'll make another video to clear a lot of it up, and then
totally.
Just like what finish your train of thought, I guess.
Yeah. So a bool contains kind of some boilerplate app state, and this kind of gets into how like DAL events are processed and handled. So for every event, there's sort of a label, essentially, or kind of a path. And then when you have a series of events, it kind of creates this stack of events. And all these events get processed asynchronously, like I mentioned before. So you could request to subscribe to another like Twitter feed from somebody else's ship. And if that doesn't exist yet, because they haven't like created their app, it'll just wait until somebody starts their Urbit or starts their Twitter app on their Urbit. And when that does happen in the future, that will asynchronously get processed, and then you'll like magically subscribe. So for every event, there's kind of this general like metadata of like, you know, what was the current time at that when that event was generated? You know, who produced that event? What was the source of the event? Are there a list of like subscribers generally to my app that I need to like propagate changes to? We'd actually look at the if we go, let's see, rep arvo zeus.ping bool. Oops, sorry, I messed that up. Actually, we should just like this up.
Is what you're getting at here that you can like debug the state of your app in real time?
Basically, yeah.
But I mean, like you'll be able to view the global app state of any web page being served because it's just.
Yeah. So like when you process like an event incorrectly, or if in any case like you just mess up your app somehow, assuming you had, you know, if the app doesn't work, it won't start in the first place. But if you're able to start your app successfully at one point, and then you make an error at the next point and it doesn't work, it'll just keep running the last working version until you kind of fix your errors. And if you do that, then it'll make the swap. So here, bool is defined. Again, this is totally a lot, and none of the syntax is kind of a lot. But we're defining a data structure here. So we're defining what kind of the standard boilerplate app state is. So there's sort of the host ship, the source of the event, the app that this is coming from, a list of subscriptions, and then these are sort of like labels. So kind of the label for the event, which is just a number on sort of your stack that you can address as a unique identifier for each event. And then there's some random entropy, so you can do stuff like random number generators and whatnot, current time, blah, blah, blah. So going back to this, all this is saying is like, we want to have all this stuff in our kind of default boilerplate app. So we're gonna pass this in as part of the sample, and it's gonna default to sort of the default value of that structure, and we're gonna give it a name called bow. So later, when we want to find out the current, like the time that an event occurred, we can just go like, you know, now.bow, for example, which is sort of it's the opposite syntax of like JavaScript. So in JavaScript, you go like this dot blah blah dot whatever, whereas in here it's the opposite. So you go this within something within something. That was kind of a lot, but let's see. I think it's let's just kind of skim over this quickly so we can wrap up. And all this app is doing is when you call this from the web, and you let's actually just load the JavaScript here because it's easier. So when you bind to this path /web and you send this herb.bind command to air, and you're specifying the app target, eventually this is going to get processed by Gall, and it's going to look in the app hello. Because this is a bind, it's going to look for an arm called peer whatever the path is. So in this case, we have peer web. So this is the arm, or essentially the function or computable attribute that gets called upon your Urbit receiving the herb.bind request from.
So every app will have something like that.
Yeah, every app will have a. Well, I'm
assuming that's just.
There are trivial apps that don't have these.
Yeah, but I'm assuming that's just a function, like in the Hoon syntax, the ++. Like I don't actually know, but
it's just kind of it's a little bit different, and we can go into why. It's important to understand the differences because it's actually sort of a new paradigm generally. But for the current time being, these are just functions. So really, so this rune bar tis, which we call a gate, is the closest thing to like a true function and a true programming language, which is like this thing produces one output and it takes an argument, which is this. So this is a function which takes a path. What this function produces, and this is what this syntax is indicating, is it produces a list of moves and the current state. So if we scroll up a little bit, again, it's a little bit confusing, but it's kind of modeling a general pattern that is very consistent among Urbit apps. And there's a lot of clearly a lot of overhead for this stuff, but actually it's in a way it's kind of a trade-off. It's like, well, you can learn the easy thing in say like JavaScript land today and get an app running in 20 minutes, but then tomorrow it's going to be gone and replaced by some other framework. On Urbit, it's a little bit harder, but it's still not orders of magnitude harder to learn this stuff. But once you learn it once, the idea is to almost literally freeze this operating system so that there are fewer and fewer changes as time goes on. So learn this thing once, and if this thing does actually succeed, and if it works, concisely and well, then you learn this thing. And then the cool thing about learning this thing once is and by adhering to these very sort of formal standards, is if you look at anybody's code, you can know immediately what's actually going on, and there's not going to be that case you see so commonly of your sort of DSL hell, where everybody invents their own language and their own terminology and blah blah blah. Cool. I don't know if you want to budge in if you have any final sort of questions.
No, honestly,
we can keep going. I think we can keep going for another 5-10 minutes just to finish the kind of the high level overview.
Yeah, I was going to say, I think as long as you just finish the train of thought that you're on, I think it's a good place to wrap up, and we should film a part 2 pretty soon. I'm just going with it, but yeah. Totally.
So basically, just to finish the train of thought, the sort of core, the concept of an event in the Arvo system generally is called a move. So when you produce a move, it's producing a state change to your Urbit system. And of course, this is all purely functional and transactional. So you record every single event or every move in your event log. And then if you replay all these events, similar to kind of your own personal blockchain, it's going to produce the same state at the end, no matter what, if you run this from the beginning. So simply put, a move is it's a pair of what's called a bone, which is just an identifier. It's just a number. Kind of going back to that stack of events. So just a number where you can look at the stack of events and refer to something by, this is event number 42 or something. And then a move has a card, and a card is basically, you think of you're playing one of many kinds of cards. In this case, we only have one kind of card for this app, which is a diff, but you could send, you could actually send produce a move that produces a peer, for example. So if you wanted to, similar to how from the web, we're calling that peer arm through an XHR request via Urbit.js. If you were to do this with Hoon over, by producing some output from a Gall app, you would produce a move that says, I'm going to give this move the current sort of identifier as is currently registered in my Gall application state. And I'm going to label this as a peer, and I'm going to subscribe to a path. So in this case, maybe it wouldn't be peer web because I'm doing over here. It might be something like peer, whatever, peer example path or something, peer hello path, right? And if you produce that move, and that was received by an Urbit, it would give the indication to run whatever arm was in that core of that app, produce that output, and then send that back to the source Urbit.
Yep, got it.
Okay. So a diff in this case is the only card we're producing, and it's basically the result of of subscribing to somebody. So when you subscribe to somebody and you want to get something back, you're getting a diff. So it's like if you were to git pull right from a repository, there's going to be some diff between the former state and the current state. So when you initially subscribe, when you initially peer, of course, you're subscribing for the first time. So you have no state of whatever you're trying to subscribe to. So you're going from nothing to, something, the latest state. But then if something changes, you'll automatically get that change propagated as a subscriber to that path. And we'll see this like in WebTalk, for example. When we were viewing, you were noticing that talk messages were loading in real time because we're subscribed on a path and your Urbit is watching for those changes. And whenever those changes occur, it registers your web session as a subscriber to that path and it propagates those changes automatically.
So when we were subscribed in the talk REPL, it's basically the subscription rights to the file. Like that's the thing that's so crazy because this workflow makes sense on the web because anyone that's done a stateful web UI knows that you can subscribe to changes and automatically.
It's hell, yeah.
Yeah. Right.
Yeah.
But doing it just on an operating system is interesting, I guess. It's something to really wrap your head around. So.
Yeah. So I mean, you can imagine sort of how the Bitcoin or Ethereum propagation mechanism of a new transaction or a new event occurs. There's, they have their own mechanisms for finding peers and sending those along, and then eventually these kind of distribute across the network. But you can imagine if you just kept a log of your subscribers, you could just send these, and if you had their IP addresses, which were stable, then you could just send these automatically.
Well, you kind of do. I mean, you have a list of peers that you're currently connected to.
Sure. Yeah, I guess that's true. I'm pretty naive to the actual technical implementations, deep into those things.
Cool. Yep.
But nonetheless, so all we're doing is when we call pure web, we want to produce a list of the moves and some state.
Yep.
So.
That is kind of interesting. So that actually makes sense when it's you're saying that what you actually produce out of these functions are an array of different moves. You call them moves, but they're state changes. It's
so you're either producing you're producing either or both a move, which is kind of an event, which is potentially globally it's kind of a general operating system level event.
Yeah.
Or you're just changing your own local state, that's a local operation. So for example, what we'll see in the next series is if we got a tweet and we wanted to keep a record of all the tweets that we've gotten, you would just change your state immutably. You make a mutant copy of your current state with the new tweet appended to the front of, let's just say, it was a list. So it'd be old list and then new tweet appended to the front of that.
Right.
And then if you wanted to, if you were the person who posted the tweet from your own Urbit, when you post the tweet, you would want to have a move in your poke arm, which a poke in Gall is the equivalent of send on the front end. It's just the mechanism to produce a state change. You want to produce a move that sends a diff to all of your subscribers.
Yeah.
So this move that we're producing os.bo just means we're just giving it the label of the current event in our state thing, just an identifier. Diff says we want to send a diff to whoever's subscribing to this thing. It's of the mark hello world, which we've defined in a file called hello world. That's a mark file. And it's LO, which is the sample, you know. And then we're not producing any state changes. So this syntax, it looks like alien gibberish, but once you understand, this will really make sense when we go through sort of core knock and just generally how Hoon and subject-oriented programming works. But basically, when you're running this whole core or sequence of Hoon logic, you're operating this against a subject, which is a data structure that is basically all the stuff that you're computing. So in most programming languages, you have this concept of scope or the environment, where it's like if you define a variable here, you know, and then you have another variable in outer scope, these scopes kind of nest and you can access these things, you know. And then some languages have different kinds of scope.
Right.
But in Hoon, you know, like in those languages, you can't actually like pull out that environment, that scope. It's not a first class value. Sometimes it's a second class value. There's some weird ways you can do it, but it's not natural. In Hoon, it's just the subject. You have this kind of tree. It's a tree of the stuff that you're computing. And whenever you compute stuff, you're operating on axes within the tree. So it's basically a binary tree, and you might have, let's just say, a counter, or well, in this case, so actually that's exactly what the syntax means. What we're saying is that in your subject right now, that's what this buck means. It's like kind of the current. So it's not totally accurate, but we'll just say right now it's the current subject. What we're saying is your state is stored, and plus means the head. Everything's a pair. A cell is there's a head and a tail. So your state is stored in the tail, and then take the tail of that, which is right here. And that's what we actually want to change. So if we were to change this, like if we wanted to change LO to not say hello world, but, you know, foo bar baz, we would use this kind of syntax. And all this means is we're going to call this arm buck. And within that arm, there's a value called LO, and we're going to change it to this value. We're essentially making an immutable copy and then doing logic on that. And when that's done, we're going to produce this whole thing as the result of calling pure web. But we're not producing any state changes for this arm. We're just producing a move, and we're producing our state unchanged. So we're just basically saying, we're producing, you know, we are emitting a move, but we want to produce our state as is unchanged. So this is effectively just a pointer to this spot in the subject. I know this is totally a lot, but when we go to knock, it'll actually make a lot more sense, hopefully.
Yeah. Cool. Yeah. This was awesome, dude. I actually think like every time I talk to you, I get further understanding this. So as long as we can just keep pushing, like I'll probably get there eventually.
Yeah. I mean, yeah. I mean, even just talking about this for this long.
But no, honestly, what I think we should do is I think we've done like 2.5 hours already, right? So I think that we should throw this up on YouTube, and let's plan to do a part 2 pretty soon, like within like 10 days. And let's just get some comments from people and see what what questions they have. And then we can like start answering those and continue on and actually do the Twitter clone.
Yeah. I mean, I think this is a fairly good overview. Arguably, I think it could have been a little better, but I think like, yeah, and really in order to understand like the coolest thing about Urbit, it's kind of like, it's the coolest thing, but it's also the hardest thing, is that we provide so many tools for you out of the box to make building apps really, really easy and simple. But the problem is you have to learn this new system. Right. So the biggest, like that puts a lot of pressure on our documentation, which hasn't been great at all for, you know, foreseeable past, which is kind of my job, is to make this a lot better, you know, and doing videos like this, I think will help significantly. But if we can make that better and try to actually show people that this thing is simple and it's going to make your life better building apps this way. Hopefully that will get people, contributing, and for anybody listening who's kind of a hardcore, systems programmer who enjoys delving down into kind of kernel level, operating system level stuff, like in terms of the technical underpinnings of this project, it's really, really exciting. And definitely, touch base with us, get on talk, ask questions, write a forum post. At the very least, the Urbit community so far, it's small, but it's very genuine, it's very warm, and we're all super supportive of each other. So it's a fun place to be. Even if you're not technical, just come hang out. We want to have everybody along for the ride.
Cool, man. All right. Yeah. So hopefully I'll see you pretty soon on the screencast, dude. Good luck. Thanks for jamming with me.
Yeah. Shoot me the link when you throw this up. I want to send it around.
Yeah, dude. Awesome. Yeah. So Keaton, dude, let's do this again pretty soon, man. All right.
Sounds good, man. All right. Peace, bro.
Peace.
Yeah.